propanoic acid, this is propanoic acid. These are the two acids formed when this bond is undergoing cleavage. You just see I start with 5 carbon atom ketone, I am landing up with 2 carbon atom and 5. This is not of the same number, it is lesser the number. It can be even this. Now, when this bond undergo cleavage, I am putting the marker here, I have got this side 1 carbon atom, other side I have got 1, 2, 3, 4. So, I will be having 1 carbon atom methanoic acid and 4 carbon atom butanoic acid. And thus, another set of acid what I am getting is methanoic acid and butanoic acid. So, this one is butanoic acid and this one is methanoic acid. I hope everyone remembers the name with the common name of methanoic acid, formic acid. I hope all of you know that formic acid is present in the sting of honeybee, in the sting of red ant. Actually, formic acid was discovered from the sting of red ants. I have written here some 4 carboxylic acids which are formed by the oxidation of pentan-2-one when it is treated with chromic oxide. But here you see none of the acid has got 5 carbon atom. They are all having lesser the number. You can also make out, suppose if I give the 2 acid, you should be able to make out the ketone has got how many carbon atom? So, 1, 2, 3, 4, 5. So, that means the ketone from which these 2 acids are developed must be having 5 carbon atom. I can even check this part here. I have got 1 carbon atom and 4, 5, and hence this is 5. None of them has got equal number, they are all having lesser the number. I hope you have understood this. If you understood this, now in this case, I am telling there is once again a major and minor. There are 4 acids, 2 of them are major, 2 of them are minor. Where else did we study major and minor? I have taught you that in Markovnikov's, another one we did in elimination, that is Seytz's rule. This is one more rule, although the name is not mentioned in the textbook, this is Popoff's rule. If you open a refresher, you may come across that. Now, just see here, I am telling this one, this set of an acid is the major compound and this set of an acid is the minor compound. Now, what was the factor which decided what is the major and the minor? How did I get the acid? When this bond undergoes cleavage, these are the 2 acids. When this bond undergoes cleavage, these are the 2 acids. Remember that here this is the keto group. When this bond is undergoing cleavage, the keto group is going with less number of carbon atoms, there is only 1. When this group is undergoing cleavage, this bond is undergoing cleavage, the keto group is going with more number of carbon atoms, then it is minor. I hope it is clear. Like for example, now suppose if I am giving you like this compound, suppose the ketone given to you is butan-2-one. And it is not necessary that always you are going to get 4 carboxylic acid. I can even have 3, I can even have 2 also. Here like I am asking you, there are 4 carbon atom with the keto group. I am asking how many carboxylic acid are you going to get it? This bond will undergo cleavage and this bond will undergo cleavage, just like this and this. Now, when this bond is undergoing cleavage, what are the acid I am going to get? 1 carbon atom, methanoic acid, 3 carbon atom, propanoic acid, 1 set. This bond undergoing cleavage, what are the acid I am going to get? 2 carbon atom, 2 carbon atom, both the sides same, ethanoic acid. So, ultimately the total number of acid I am getting is 3. I am going to get one as methanoic acid, I am getting propanoic acid as 1 set. These 2 I am getting when this bond is undergoing cleavage, and when this bond is undergoing cleavage, I am going to get ethanoic acid. Can you make out which one will be the major compound? It can be a question in your entrance examination. Select the major acid formed on the oxidation of butan-2-one. Then which one will be the answer? I am not going to get here 4, I am just getting here as 3. So, apply the same rule. How did I get the major here? When this bond undergoes cleavage, the keto group is going with the less number of carbon atoms. Same concept. Here, if this bond is undergoing cleavage, keto group is going with more number of carbon atoms. This bond undergoes cleavage, keto group is coming with less number of carbon atom, and hence the major product will be this. So, 2 carbon atom, 2 carbon atom. So, here ethanoic acid is the major product. I hope you would have understood. So, now the entire chart is clear. Primary alcohol, you get acid, same number. Ketone, if it is 2-degree alcohol, ketone, stop there. And similarly, if I have to go further, then separately a question has to be asked, ketone to acid, like this. The third one, 3-degree alcohol, is only giving me an alkene. I hope it is clear, the oxidation part of the reaction. So the remaining, I'll be doing it in the fourth part, reduction onwards. I hope you have understood.